And what we want to do is try this exact same technique we just learned, except on a quadratic. So, we change the inequality to an equal sign. The way we solve quadratics is either the quadratic formula, completing the square, or factoring. I'm going to go with factoring because I happen to know the factors of this quadratic. And now, we graph the 2 points. Are we including them or not including them? That's based on the inequality. This is a closed inequality. So we're going to include the points. Okay? So, again, kind of like what happened over there, our graph, or our real line here, is split up into sections. Each section is either all solutions or no solutions. So we have to go through one at a time and test each one. We can pick any point we want in this entire region. I'll pick -3. Here I'll pick -3/2. And there I'll pick 0. So let's try -3. -9, 2. 2 is less than or equal to 0. So this is not part of our solution set. So I'm going to put a big F underneath that part for false. The next one, -3/2 squared plus 3 times -3/2 plus 2. Okay, we're going to need to get a common denominator. This is true. Okay. And then, of course, the last one, 0 squared plus 3 times 0 plus 2 less than or equal to 0, which is false. So our final graph looks something like this. This region was false, that one was false, this one was true. Those are where the solutions are. All right. So, the last thing to do is, of course, write our solution set in interval notation. So this is how we can solve a quadratic inequality. Notice it also works at solving linear inequalities. So we can use the same technique for either case. Generally, when we go to solve linear inequalities, we don't want to use this technique because these are so simple, we can just solve them the way we want. This one, though, there's no way to solve for x, in a sense, when you have the inequality sign. So this new technique is a cleaner way to figure out where the region is positive and where the region is negative. Or where the inequality is positive and where the inequality is negative. So this technique can be extended further. Not only could we solve quadratic inequalities, we could solve cubic inequalities or any type of polynomial inequality, actually. And in general, all you have to do is take the inequality, turn it into an equal sign, solve it, plot those points, test each region. So, Let's try one last example. Here's another quadratic inequality. So, this is open. What we're going to do, change it to an equal sign. We're going to solve the quadratic. So the way we solve quadratics is we solve for 0. We then either use the quadratic formula or factor. And then we then plot each region. So we're open, so we're going to put open circles. And we need to figure out which intervals are positive and which are negative, or which satisfy the inequality and which ones don't. So for this one, we can pick any number to the left. So I'll pick negative 10. It's nice and simple. Here we can pick negative 1, and here we can pick 1. So we try negative 10. And we see that it's true. And what we'll find is that this one is false, and this one is true, and thus we know how to solve linear inequalities and quadratic inequalities. All right.